welcome to True Projects. In this video, we are going to explain about the project that is a comparative analysis of Lyme and SHAP interpreters with explainable machine learning based diabetes predictions. So before getting into the execution, first let us understand what is the project about. So in healthcare, clinicians they often rely on predictive tools to assist in diagnosing diseases such as diabetes. Diabetes. It's a chronic condition affecting millions worldwide with particularly high prevalence in developing countries. Early and accurate detection is essential for effective management and to prevent serious complications. Here, machine learning models have the potential to improve diseases prediction, diagnosis, and also treatment planning by analyzing complex data sets and identifying patterns that may not be immediately apparent to healthcare professionals. However, many machine learning models operate as black boxes, that is, providing predictions without explaining the reason behind them. This lack of transparency can reduce trust among clinicians and make it difficult to adopt these models confidently in real world clinical settings. For predictive tools to be effectively integrated into healthcare, it is crucial that they not only deliver accurate results but also provide clear and interpretable explanations of how these predictions are made. And one of the biggest challenge that is using with the machine learning in healthcare is that although these models can predict diabetes accurately, it is often unclear how they arrive at their predictions. That is, clinicians may receive a prediction, but they cannot easily understand which factors influence the result or why the model gave a particular outcome. This lack of clarity can make it difficult for healthcare professionals to fully trust the model's predictions. So, as a result, even highly accurate models may not be used effectively in real world clinical decisions. Without transparency, doctors may hesitate to rely on these models, which limits their practical adoption in healthcare. The inability to explain predictions prevents machine learning models from being seamlessly integrated into routine clinical workflows, reducing their overall impact despite their predictive power. So here, to overcome with the challenges of non-interpretable machine learning models, the system first builds a diabetic prediction model using several popular machine learning techniques, including logistic regression, random forest, decision tree, and cat boost. So the dataset is carefully pre-processed and analyzed to identify the most important features that contribute to the predicting diabetes. Once a model is trained, explainable AI models are used here. So, explainable AI techniques are applied to make the predictions understandable. First line, that is, local interpretable model diagnostic explanations are used to explain individual predictions showing which features influenced a specific outcome. And also, SHAP has been used. SHAP is shapely additive explanations. So, this provides a broader view of feature importance across the entire model. So, by comparing these two interpretability methods, the system helps to clinicians see not just what the model predicts, but also why. Make the predictions more transparent and trustworthy for real world healthcare decision making. So, this is what we have proposed in this project. And to further improve the performance of this project here, as an extension, the project introduces smooth technique. So the issue of the data balance was addressed by applying smooth technique, that is synthetic minority oversampling technique, which generates synthetic samples for underrepresented classes to improve the model training. And also for improving the performance purpose, here we have integrated voting classifier, which is an ensemble model. Here, voting classifier combines XGBoost and Light GBM, leveraging the strength of both the algorithms. In addition, here we have developed front-end using Flask framework to enable practical user interaction and also testing. And the interface is user-friendly, allowing users to input relevant data and view predictions easily. And also with this front end, we have integrated user authentication mechanism. So this makes the system both accessible and safe for the use of users. Now moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So let us understand them, each of them. First, we have imported the necessary libraries, that are Python packages and libraries required for data processing, model building, evaluation, and visualization. Then comes loading the dataset. So here, diabetes dataset. Here we read the diabetes dataset into the working environment for analysis and model development. Then comes exploring the dataset. So here we examine the dataset to understand its structure, feature types, missing values, and overall data distribution. Then comes pre-processing. So here we convert categorical variables into numeric form using label encoding to make them suitable for machine learning models. Then comes data visualization. So here, first we understand the distribution of each variable by using feature column graph and the target column graph. So we will be representing as the sample outcome graph. And then comes correlation matrix. So here we identify relationship between features and the target variable using correlation matrix. And in the sixth step, here we separate the dataset into input features, that is X, and the target variable as Y for the model training. So in the next step, we handle class imbalance by generating synthetic samples for underrepresented classes to improve the model training. Here we will be using SMOTE technique. Then comes train and test split. So here we will be splitting the data into training set and the test set. Training set is used to train the model and testing set is used to evaluate the model. After that, we will be initiating all the machine learning models and then we will be training them on the data set where data balancing has not been done, and also we will be training the models on the data balanced data set. After that, we will be evaluating all the models using the metrics that are accuracy, precision, recall, and FN score. And that scores will be visually represented through graphs. And we will be saving the best performing model for the future prediction. And then comes implementation of XAI techniques. So here we have applied explainable AI techniques to understand how feature influence predictions. That is how features they influence the prediction. So here we have used Lime and SHAP. Coming to the front end, here we have developed front end using Flask framework along with the registration and login with the help of SQLite database. So we have created a web interface for users, including registration and login functionality using SQLite for data storage. And in the front end, users they will be able to provide features as the input that will be pre-processed at the backend. It will be fed with a trained model, and then trained model will be giving us the prediction, predicting the diabetes. And moving on to the algorithms. So these are the algorithms used in this project for predicting diabetes. To implement this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, let's open the code folder of the project. So these are the source code files. And here in this folder, we have the dataset that is used. So these are different files. Get back. And here in this model folder, we have the algorithm information that will be loaded into the project code during runtime. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the notebook file. It's a Jupyter notebook file, which contains a combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the sample file. This file we will be using in the front end for test cases purpose. This is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. Copy it. Now open Anaconda prompt. Here it has opened. Now give the command cd, give the space, paste the copied path, and now click on enter. Here if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. So now copy this local link provided by the Flask framework and paste it into any web browser. I have copied the link. I prefer Google Chrome, so I will paste it in that. So paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this is the web page of the project. To start doing the prediction, we need to sign up first. So click on sign up and create the account. If you have not created, you create the account and then sign in. I have already created, so I will directly sign in. Click on sign in. Give your username and the password. So I'm giving my username and the password. Now click on sign in. We have redirected to prediction page. So this is the prediction page. So here you can see the inputs, right? So these are the parameters that we are supposed to give for predicting the diabetes. So let's understand what the parameters are. The first one which we have is the high BP. That is nothing but the high blood pressure. It indicates whether the person has high blood pressure. That is the hypertension. Then we have high call. That is nothing but high cholesterol. So it indicates whether the person has high cholesterol levels. Then we have call check. That is cholesterol check. It shows whether the person has had their cholesterol checked by healthcare professionals. Then we have BMI, that is nothing but body mass index. It is a measure of the body fat based on height and the weight. And here, the next parameter is a smoker. It indicates if the person currently smokes tobacco. And then we have stroke. It indicates whether the person has had a stroke. And then next we have heart disease attack. So here we have heart disease or attack. It indicates whether the person has had heart disease or heart attack. Then physical activity. It is nothing but physical activity. It indicates whether the person engages in physical activity or exercise regularly. Then we have fruits. It is nothing but it indicates whether the person consumes fruits regularly or not. Same veggies also, that is nothing but vegetables. And then we have heavy alcohol consumption. So it indicates whether the person consumes alcohol heavily or not. And then we have any healthcare. Here it indicates whether the person has access to any form of healthcare. And then we have no dog BC cost. It indicates whether the person did not visit a doctor due to the cost issues. Then we have Gen Health. It is a general health status as reported by the person. It is excellent, very good, fair, like that. Then we have mental health. So it is the number of days in the past month that the person's mental health was not good. Then physical health. It is the number of days in the past month that the person's physical health was not good. And then we have diff walk, that is, it indicates whether the person has difficulty walking or climbing stairs. Then the sex is gender of the person, age of the person, what the education he has, and what does he earn. So this is all about the parameters. Now let's enter them. For that, let's open the test cases file. So here we have sample. So open that, in which we have test cases. It's opening. So here test cases has been opened. Let's enter them step by step. So first, let's apply filter to the target variable that we are predicting. So this is the target that we will be predicting, and we will be not entering this values. Only we will be entering other than the target column. So let's apply filter to class 0 and click on OK. So here, first, here we have high BP 1. That means person has high BP. Cholesterol, he has high cholesterol. And here, cold check, that is 1 means it is yes. Body mass index is 40. Smoker, he smokes. And the stroke, he has no stroke. 0 refers to no stroke. And heart disease, so here, heart disease attack is 0. That means no. Physical activity is also 0. That means no. And he doesn't eat fruits. So here we can see 0. So let's select it as no. He eats veggies. That is 1. Yes. And alcohol consumption is 0. That means he doesn't consume the alcohol. And any healthcare, that is 1. It means yes. Here, no dogs cost. It is 0. So no. General health is 5. Mental health is 18. Physical health is 15. And if walk it is 1, that is yes, that is he goes to walks. And the sex is 0, that means he is male. Sorry, he is female. And the age is 9. Education is 4. Income is 3. Now click on predict. So this given input, it will be pre-processed at the backend. It will be fed with the train model, and then train model will be giving us the prediction. So just wait for a while. The process is being happened at the backend. So here you can observe diabetes has been detected. Here we got the prediction that is diabetes detected. And here the model predicts that may be suffering from the diabetes. Please consult. That is, it is advising to consult a healthcare professional for the further advice. Here we got the result that is suffering from diabetes. And here are the SHAP model explanation. Now let's try with the another test case. So let's try with this test case here. So high BP is yes. High cholesterol is yes. Cholesterol check is also yes. Body mass index is 34. Smoker is yes. He's a smoker. And then stroke is here we have 0. That means it is no. Heart disease attack is also no. Physical activity no. Roots yes. And here we have veggies yes. Heavy alcohol consumption it is no. Any healthcare it is 1. That is yes. No doc BC cause that is 0. That means no. General health is 3. Mental health is 0. And physical health is 30. And then different work is yes. Gender is female. Age is 10. Education is 5. Income is 1. Click on predict. So here we got the prediction that diabetes detected. Here we got the prediction diabetes detected, and here we have the model explanation. Now let's check with the class 1. So apply filter to class 1. Click on OK. Click on try another prediction. So let's check with this case where high BP is 0. That means no. No cholesterol. Call check is 1. That is yes. Body mass index is 23. Smoker is yes. Stroke is 0. No. Heart disease attack is also no. Physical activity is yes. Fruits 0. Veggies 0. That means no. And then heavy alcohol consumption is no. Any healthcare is 1. That is yes. 0. No. General health is 2. Mental health is 0. Physical health 0. Different walk is no. And gender is male. Age is 7. Education is 5. Income is 1. Click on predict. So here we can observe that person is healthy. He has no diabetes. And here are the model explanations. In this way, let's check with the last case. So here, let's check with this case. Click on home and give the high BP that is no. High cholesterol is no. And call check is yes. PMI is 32. Smoker is no. No stroke. No heart disease. Physical activity is yes. Fruits. No fruits. Veggies is yes. Alcohol consumption, heavy alcohol that is no. Any health, that is no. And then no dog BC, that is yes. And general health, we have it as 4. Mental health is 0. Physical health is 3. Different walk is no. Gender is female. Age is 3. Education is 5. And the income is 3. Now click on predict. We have not selected an item, just recheck. So stroke here we have. So stroke is 0, that is no. So now click on predict. So here we can observe we got the prediction as healthy. There is no diabetes for the person, and these are the model explanations. So here in this way, just by giving inputs to the application will be predicting whether the person has diabetes or no. Now let's check with the graphs. Click on about. So here we have the graph. So the first graph is a sample outcome graph. Here the blue color represents no diabetes and the orange represents diabetes. Here you can observe there are more classes of no diabetes and less classes of diabetes. So that is why we have used SMORE technique as the extension, and we have balanced the data set. So here you can observe the balanced data set. And here we have the heat map, that is the correlation heat map. It shows the correlation between the independent variables. And here we have SHAP summary plot, which shows the feature importance of high BP and high cholesterol. And here we have accuracy comparison graph. So here on x-axis we have all the models that we train, and on y-axis we have accuracy score of each model. Close this. Similarly, we have precision, recall, and F1 score. Now log out. In this way, just by giving input to the application, it will be accurately predicting whether the person has diabetes or not. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.